Here's a heat capacity question. So module 5 material. We take 1.85 kilograms of a sample and we heat it from -2 to 13 degrees Celsius, and that requires 13 kilojoules of energy, right? What is the specific heat capacity of this substance? And so our equation, Q equals mCs delta T. Q is our heat, M is our mass. Here's our specific heat, that's what we're going to look for. And then we've got our delta T. So first things first, we want to put this, typically our specific heat is found in joules per gram times degrees Celsius or Kelvin. So first things, we want to turn everything into the right units. So I've got 13 kilojoules. I know there's 1 kilojoule and 1,000 joules, so I have 13,000 joules of energy. My mass, we want to turn that into grams. I've got 1.85 kilograms, and again, I know there's 1 kilogram and 1,000 grams, and so I've got 1,850 grams of this sample. And then delta T. Delta T is always temperature final minus temperature initial. So my delta T is going to be my final temperature, 13.1 degrees Celsius minus a negative 2.6 degrees Celsius. So my delta T is approximately 15.7 degrees Celsius. Don't worry too much about Celsius versus Kelvin because the change in 1 Celsius is equal to the change in 1 Kelvin. So we can plug everything in that we've got. I've got 13,000 joules equals 1,850 grams. I don't have my specific heat. That's what we're looking for. And my delta T is 15.7 degrees Celsius. So I multiply and then divide. And I get a specific heat for this substance of approximately 0.448 joules per gram times degrees Celsius. And again, you can write Kelvin in there, it would be the same number. I would do 3 significant figures based on everything else having 3 significant figures. And then when we do the change, that also should have 3 significant figures as well.